I wanted to walk through an example of a roulette wheel. And so there's going to be a couple of them in your MML homework, but I thought that we'd go through one together. So the first one that I chose to do is looking at probability if I'm going to place my bet on a single number. And so what we've got up on the screen is we've got the idea that I decide to put a $5 bet on the single number. If I lose, I'm out my $5. So that's why we put the negative $5. If I win, the win is $180, but it costs me $5 to play. So my win, what I'm going to walk away with, is $175. So that's where that 175 came from. So now let's put the probabilities next to it. So the probabilities of winning, there's 38 spaces on the roulette wheel, and so the probability of winning is 1 out of 38. Down below it, the probability of losing is 37 out of 38, because 37 of those spaces are not the one that I picked. Then what happens is we want to talk about the idea of the expected value. So the expected value is the same as the average when we're working in this section. And so we want to say it equals the x value, so our x value, the 175, times its probability, the 1 divided by 38. So 4.6053. Then on the next row, I want to take the negative 5 and I want to multiply it by 37 over 38, and I get negative 4.8684. Then remember, when you're calculating the average, you have to take that column and you have to sum it. So we have to take that column, that x times p of x, and we need to sum that column to get the expected value. And so that's what's going to happen next, is we'll do x times p of x and sum them down, and we get 0.2631 negative, and so that's the expected value. So you're expected every time you go up to play roulette to lose 26 cents. The extension to this problem that a lot of ours in our book do is part B. Well, what if I made 100 bets? What would be my loss? And so we'd say for a total of $26, if I stood there and made 100 bets, that would be what I would lose during that time. So now let's look at a second scenario. So let's say that I'm going to bet $5, and this time I'm allowed to bet on 2 numbers. And so my probability of a win, or I'm sorry, not the probability, the money for a win is $85, and the probability that I lose is negative. The money that I'm going to lose is $5, so the negative 5. So again, now because I'm picking 2 numbers, I'm 2 out of 38. And then if I lose, I got one of the other 36 out of 38. So when I go across and I multiply those again, the x times p of x, I get $4 or 4.4737. If I lose, it's a negative 4.7368. Then when I sum that column down to get the expected value, it's negative 0.2631. So that's my expected value every time I go to bet the $5 on 2 numbers in this idea of roulette. So the interesting thing, so look at how the number is exactly the same when I'm doing a single number as opposed to the two numbers. Then again, remember your column should always add up to 1, so we should sum to 1 when we're looking at those values. And so again, if we did another extension and we said, what if I made 100 bets of two numbers, we'd say as we stood there and made 100 bets, I would lose $26. So I hope this helps you going through those few roulette problems that you have on the homework this week.